right, so now we want to enter into the final phase of setup, really, before we run the program, and that's going to be our verification phase. So there's a couple things to do. The first, we want to actually do a verification of our offsets. We want to make sure that we set our fixture offsets and our tool length offsets up correctly. So we'll do that, and then following that, we'll go into and do a verification of our program. So now we'll jump in and do a verification of our fixture offsets. So the machine has been returned to the home position, and essentially all I want to do is tell the machine to move to a known location above our stored fixture offset that I can then use a gauge block, for instance, to check and make sure that we in fact can move to that home location correctly. Easiest way to do that is to go into MDI mode. So we'll cycle through until I get to internet command prompt, hit manual, get me in the MDI mode. And now I just want to type in the G code to move me to that particular location. So, of course, what makes sense, let's just move to the origin of the fixture offset that we set up. So we used the first fixture offset, which is going to be fixture offset G54. And we can move to the origin of that in X and Y, check that setup, and that'll ensure that we did our edge finding right. And then we'll bring the tool down to a known height in Z and use our gauge block to check that. So I'm just going to type in G code here into the MDI interface. I need to identify which fixture offset we were using. So it's a good idea. I usually like to suggest that you make sure that you're in rapid travel. So we'll start with a G0. Make sure you're referencing absolute coordinate systems, so a G90. And then our fixture offset is fixture offset 1, so G54. And then we want to move to the origin of G54, so X0 and Y0. So I'm going to go X0 and Y0. Now note, I'm not typing any spaces in between these lines. You can type the space if you need to, but the controller does not need them. Spaces are primarily for humans in order to make it more readable, but the machine can totally understand all those codes without spaces in there. So I'm going to hit enter. And then it's going to drop into the waiting state. And now I want to move over and take advantage of these two positions right here. Because what I want to do is be in a ready position to pause motion if the machine starts to go in some direction other than what I anticipate. So right now I expect the machine to move the table underneath the tool. And if it starts moving in any other direction, I'll pause that motion using my slide hold button and then check and make sure that I didn't mess up my code right. So I get myself in this position right here, put one finger or one thumb on the green button and another thumb on the red button, and I'll press start and let that move over. And sure enough, that looks like that's lined up pretty good. So at this point, you want to kind of eyeball your X direction and eyeball your Y direction and look to see if those are right. Now, if they're definitely off, you can go back and check your fixture offsets, or if they look good, come down in Z and then make another verification at this point. Now, before you come down in Z, I'm going to suggest that all of you newbies out there, make sure that your rapid travel override is shifted into 25%, so the lowest rapid travel rate. And now we're going to tell the machine to come down in Z. So let's go ahead, and since we used the 3-inch block for all of our tool setups, we'll go ahead and move to 3 inches above our stock height in Z. So I'm going to just tell it, we're going to go to 3 inches, so 3 dot. But we also need to implement our tool length offset because we have tool 1 in there, and in order to get that tool down to the appropriate height, we have to utilize the tool length offset that we stored. And that is accomplished by using the H word for the particular tool that we have. So in our case, I'm using H1 because that corresponds with tool 1, which is currently loaded in the spindle. Tool 1 is in the spindle. So Z3H1 should put that tool 3 inches above our part. So again, I'm going to do the same thing. I'm going to get myself positioned over here. So I got my finger on the slide hold button at the ready. Now when I press enter this time, the machine is not going to go in the waiting state. It's going to immediately start to move. So I want to be in position to pause it if there's a problem. Here we go. Pressing enter, machine starts to come down. I can press slide hold at any time and take advantage of my display here and the information that's given me. So again, this is our current location relative to our fixture offset, and this is going to be the distance we have to move, or distance we have to go. So we need to move down another 4 inches, and I want to make sure that I have physical space. I have 4 inches more physical travel before I crash into something. If I don't have that, then I know I've got an error, and I would pause and go address that. But right now it looks good, so I'll go ahead and continue by pressing the green button and letting it continue to come down. And again, I can stop it if I need to, but that looks pretty good. So the machine has come to rest. We'll grab our 1, 2, 3 block and use this to do a verification of our height. And sure enough, that slides right under just like we did at the previous setup. So at this point, we can consider that our tool length offset for this tool and our fixture offset are correct. We have one other tool. I always suggest you check on 2 tools, so we'll do a quick check on a second tool, and I'll do that by doing M6, and we'll change to tool 2. Go ahead and execute that tool change. And then the same thing, we're already in position in X and Y, so all I need to do is bring this one down 2, 3 inches above our part. So the same process, we're just going to do a Z3 dot. In this case, however, we've switched to tool 2, as indicated right here. That means I need to utilize H2 for that fixture offset. And then get myself in the ready position, press enter. I can pause it on the way down, check my distance to go relative to actual physical distance remaining. So I got 1.5 inches to go, got plenty of distance before I crash anything. That all looks safe. So I'll go ahead and let it continue the motion. And let it come to rest, and then we can check again with our 1, 2, 3 block, and that's good. All right, so we have verified that our tool length offsets and our fixture offsets are correct. So once that's complete, then we can tell it to go home. This time I'll just use the HO command at the enter command prompt, enter, and let the machine return home. So the next step that we want to do in our verification is to do a verification of our code on the machine. Now, if you have a relatively short program, this is a valid way to do it, and certainly for the happy face programs for your qualification demonstration, you'll want to do this. It gives you an opportunity to check the code and then make an edit if you need to. When you're done with your qualification and you're doing long programs, this is not a very efficient way to go about troubleshooting. But for the shorter stuff, it works, and I'll demonstrate it here. So again, I want to go back into graphics mode, so I'm going to use the space bar to cycle me through until I get to the graphics option, and press G, and I'll just auto draw this to backplot it. Now I have some idea what this program should look like. So here's our sample happy face, but I can see I've got kind of an errant line going on over here, up there in that upper corner. So that's a problem, I know, because we've written this program. We have a drawing or a guide that tells us what it's supposed to look like, but that is incorrect. So I need to do a little troubleshooting to figure out where that error is coming from. So what I'm going to do is utilize the single step mode in the backplotting routine to figure out where that is. So if I use the S key, S for single step, that'll allow me to step through the program one line at a time, or one block at a time. So you can see that as I press S, I'm cycling through various lines, and we're starting to draw the outline or the border of our program. So right there, on line 13, I can see that that's where that error shows up. And I can look at that code and see, oh, that says an X1 instead of an X minus 1. So that line should go this direction, which would be a negative X move instead of a positive X move. So I can just make that edit. I figured it out. So I'll finish plotting, go to space bar, and hit X for exit. Hit my space bar until I come down, and I'll just use the down key in this case to cycle me down to line 13, which is where we found the error to be, and make that quick change. So I just need to change that from an X plus 1 to an X minus 1. So C for change, type X minus, whoop, I made a mistake, so backspace, X minus 1 dot, and hit enter, and then enter again to write it. And then that should be in there, and I can do a quick verification again by going into graphics mode, and then auto draw, and sure enough, that cleans up that error. And now we know our code is good to run, and we'll be able to set up in the final verification segment next.